Hello. I'm going to explain to you here how this ventilator works that was developed with common industrial components. The goal here was to test the feasibility of automation of solenoid valves using compressed air as a source as an approach to an open source ventilator. This ventilator uses a common industrial mask of the style used by painters, construction workers, so on and so forth. It's a cartridge respirator mask. This is a size medium. It's made out of silicone. I've removed the plugs that are in the sides that usually accommodate the respirator cartridges and replaced them with plugs that are threaded to accept these pressure relief valves. These valves will vent at 0.5 psi if something were to go wrong and the pressure were to go too high. There's a custom plug in the front that allows attachment of the silicone tubing for supply of air. The supply tubing's been fitted with this optional pressure sensor for monitoring the face mask pressure during use. That's not essential to use, but does provide useful information on how well it's functioning. The air is supplied and removed through two tubes. The use of two tubes is important as one only flows for inhalation and one flows for exhalation. This prevents recycling of air. That would be the case in a single tube. You would recycle exhaled air. So the use of two tubes and a Y adapter close to the mask creates smaller dead volume and prevents recycling of air. The air supply is controlled by these solenoid valves. I put quick connect couplings on the valves to allow easy removal of the air supply lines. And there's a third quick connect coupling on the valve that controls the exhale portion. This could be used to attach the exhale air to a filter or decontamination unit to prevent exhausting of infectious particles into the room. The air supply comes in here. This is just hooked to an industrial air compressor. However, an air supply suitable for breathing should be employed if this were to be used on a human. We have a particulate and aerosol filter here. This filter is by no means intended to be medical grade, but the point is there should be filtration of the air supply. This is a precision pressure regulator. It's a high volume, low pressure style. You need to be able to flow a fairly significant volume of air at the low pressure used for ventilation. Ideally, the pressure should be 0.5 psi max. This unit functions best at about 1.5 psi, and that is due to the restrictive nature of these valves. Now, in the paper I write, I discuss what flow coefficient would be more appropriate for a valve to function at lower pressure. Now, just because you're using 1.5 psi here doesn't mean you produce 1.5 psi in the supply tube, since there's a pressure drop across the valve. You could see in my paper that 1.5 psi here results in about 0.3 psi ventilation pressure, which worked successfully when I tested this on myself. The solenoid valves have solenoid coils that operate on 120 volts AC. The 120 volt power comes through this cord that's just plugged into a standard wall receptacle. 120 volts AC is standard house power supply here in the United States, so that's what that's plugged into. Solenoid coils that work off DC, AC, or various voltages, whatever you really have access to, could alternately be employed. However, the electronics that control them may be slightly different. Here, the solenoid valves are controlled with a computer program. The computer program utilizes this data acquisition card. This is a LabJack model U6 Pro. It attaches the computer via USB, and it allows, it sends a 5-volt signal to these solid-state relays that'll turn the valves on and off. It also accepts input from the analog pressure transducer for monitoring of the face mask pressure. Again, the pressure monitoring is optional, but useful. Now, When the solid state relays receive a 5-volt signal to this side, they switch the 120 volt high voltage on that side to turn the relays on and off. Now this is 120 volt AC. It'll shock you if you touch it. It should probably be insulated, but again, this is intended to be a proof of concept. Here's an explanation of the computer software that controls the ventilator. I apologize about the distortion. I only have a GoPro with a fisheye lens to film this. The program was designed to be very simple. The control function is all in this portion. There are really only 4 controls. A button here in the upper left that will open and close the exhale valve. When it's open, you can see this green virtual LED becomes green to show that it's open. This is useful for putting the mask onto someone because they can breathe freely through the exhale tube while this valve's open. The other button initiates the automated ventilation cycle. I'll press that, and you can see a ventilation cycle begins. Now you don't see any pressure displaying on the graph because I don't have the mask hooked up to someone. It's just venting into the atmosphere, so there's no pressure buildup. The 2 controls that control the automated ventilation cycle are the breaths per minute and the exhalation to inhalation time ratio. I found with this unit, at least testing on myself, that 8 breaths per minute and an exhalation-inhalation ratio of 3 are appropriate. These values can be edited with the sliders or by clicking on the respective value and typing it in. I'll turn it up to a fast rate of breaths per minute so you can see that it cycles faster. Similarly, we could turn the exhalation-inhalation ratio to 1. In this case, it's using an equal amount of time for the inhalation and exhalation. And you can see the strip chart here gets marked with red and black lines showing when the inhalation and exhalation valves are open. We'll use this direct data entry function to set these parameters back to more realistic settings. And then for display purposes, the time of a breathing cycle versus the inhalation and exhale portions in time are calculated for display. The strip chart here is used with the optional pressure sensor, which is not required for operation, but will show the pressure curve in the face mask if this was actually on a person. So yeah, that's pretty much it for the software. I'll put the thing on and see if I could show an operational pressure trace as the last part of the video.